Hello students, today we are going to discuss the property 6, which is the last property of this chapter. So last class we have studied up to property 5. So have a look to property 6. Here, if to each element of a row or column of a determinant, the eq multiples of corresponding elements of other row or column are added, then the value of the determinant remains same. It's little bit lengthy. I will show with an example, then it will be more clear. Okay. If delta be any determinant, let it be A1, A2, A3, B1, B2, B3, then C1, C2, C3. This determinant is delta. Now we are going to perform the operation. This row is going to add with first row with a constant k. Okay, then we will get a determinant as delta 1, which is now A1 plus KC1, A2 plus KC2, then A3 plus KC3. Then remaining B1, B2, B3 as such, C1, C2, C3 as such. Okay, so looking this, we can read this property once again, then it will be more clear. Here, to each element of a row or column of a determinant, the eq multiples of corresponding elements of other row. So here R1 is performed by R1 plus KR3. Correct? This row is called R3. This row is called R1. We have added a constant with this row C1, C2, C3. First we multiplied with a constant K. Then it is added to the first row. This is called the eq multiples. So the eq multiples of other rows are added with the first row. Then the value of these two determinants will remain same. That is a property 6. That is, we need to verify delta and delta 1 is actually equal. So we can verify this proof. So students, we are going to verify this property 6. So here delta is a determinant A1, A2, A3, B1, B2, B3, C1, C2, C3, and its delta 1 we got by adding the q multiples of row 3 to the row 1. So how we can verify these two determinants are same? You have to prove delta and delta 1 is same. So here, according to property 5, we can split these two terms into two determinants. Remember, using property 5. Okay. Delta 1 can be written as how? A1, A2, A3, B1, B2, B3 and C1, C2, C3 as one determinant plus other as this KC1, KC2, KC3 as other determinant. It is based on property 5. Okay. So KC1, KC2, KC3 remaining as such. Okay. B1, B2, B3. Then C1, C2, C3. Clear? Now we got two different determinants. Now just check the first row and the third row. These are proportional, correct? If we take this K outside, we will get C1, C2, C3. That means if two rows are same or proportional, the value of this determinant will be 0. So this determinant is actually 0. So we can write it as this determinant is 0. How? If two rows or two columns of a determinant are same or same proportional, okay, then the value of the determinant will be say 0. It is one property. Then this can be written as delta 1 is now A1, A2, A3. We have B1, B2, B3. Then C1, C2, C3. Plus this determinant value is 0. That means this determinant is actually delta. Correct? First determinant was delta. So now we have proved. Finally, delta 1 and delta is actually same. Here, this is delta 1. This is delta. So delta 1 is actually equal to delta, which is the proof, and we verified the property 6. Clear, I think. Okay, so keep practicing all the 7, 6 properties of determinants. Okay, then see you soon. Bye.